Cool. 702. Hi everyone. Welcome to week 8. We're chugging along. We started 8 weeks ago, I think, or 9 weeks ago. We took a break. I don't know. And until now, we have reached a state where I think, hopefully, a few of you, maybe all of you, can create a basic front end and back end, at least in JavaScript, if not TypeScript. Okay. So what did we understand until now from the beginning? If you were a complete beginner, you understood JavaScript, you understood what backend servers are, you were able to write your own backend server for a to-do application. We did basic HTML, CSS and JavaScript, React, and then we moved everything to TypeScript. React May specifically, we did something called recoil for state management, understood what is re-rendering, and understood the basic syntax of React. Cool. Why this recap? This recap because this is a good checkpoint. At this point, you can hopefully create a website. We have created a few CRUD websites now, a course selling website, a to-do application, and we will create a few more. I will take a bunch of classes now where I'll just take a random website and code it. For example, we will be coding StreamYard most probably tomorrow or either somewhere in the week. And a lot of React Node.js will come via a bunch of practice. And a lot of you wanted a bunch of breaks before we start the open source section. Rather than taking breaks, I just want to teach more advanced concepts, because if you know these advanced concepts, it will be much easier for you to cruise through the open source part. You'll be able to understand repositories well, because the concepts that we're learning today and we'll probably learn over the next few weeks are very commonly used in most open source projects. When you open an open source project, you're already looking at a lot of new things, a lot of new modules, a lot of developer specific code. Everyone has written code apne hisab se, according to their needs. Developers are very lazy that way. So you are already struggling a lot. We don't want to struggle with more things that we can learn upfront. So this is the time to sweat a little and learn more things that are very commonly used everywhere. Also why they are used, also why they're industry standard, why you should use them in your own personal projects as well. But more specifically, why they are used throughout the industry in all open sourse projects. And if they're not used in an open source project, how you can introduce that in an open source project and gain some brownie points. Cool. We'll also be not really making an open source contribution by the end, but if you're able to finish through the slides today, because I have a bunch of things, I'll show you a place where I see a place where you can improve something in an open source sort of repository. That repository is closed source for now. It's Backpack only, and Backpack has gone closed source for a month or so because some private things are happening. But whenever it opens back up, you can contribute to it. If not, at least you understand that there are repositories out there. There are unoptimal things there, how you can make them optimal and gain brownie points from the contributors. Cool. So that is the gist of what we're doing today. More specifically, what we're doing is some more TypeScript. We have done very basic TypeScript until now, and it is enough for you to build any project. For example, a CRUD application like we've built, the to-do app. Hopefully a few of you, all of you have already gone through last week's assignment, which was this assignment right here. 7.3. Yeah, this assignment on TypeScript where we moved a JavaScript project to a TypeScript project. If you did, then today's class should be easy and you'll be able to just marinate a lot of new concepts and do a bunch of things. This will be a very assignment based class, so it'll be very hands-on. If you have not done this, if you don't understand React yet, if you don't understand TypeScript yet, then maybe either skip this class for now, go back and just practice, create a bunch of new React projects and then come back to this video. Cool. What are we learning today? Some more TypeScript, more than what we've learned until now. Zod, a library that's used very commonly for backend validation. We'll also understand what backend validation is and why you need it. We'll try to create some custom hooks using this thing by hand. Like we will ourselves create a bunch of custom hooks. This will be the open source contribution that I'll show you. A bunch of places in Backpack we do fetches the wrong way and how you can optimize it using custom fetch hooks. And finally, we might go through this library called use SWR or SWR specifically, or might not. We don't really need to. What we do here is something that this library provides us out of the box. We'll get to it when we get to it. Cool. I hope you guys are excited. Let's get right into the video. So we're going to do some TypeScript practice now. So I would urge you all to open Replit and select a TypeScript playground. You can do it locally as well, totally fine. Just create an index.ts file locally, but just so that things are easy and we can sort of work fairly quickly. let's open Replit and let's create a empty TypeScript playground. Cool. I'm going to wait for 10 seconds for you guys to do it. Cool. First thing you have to do is create a function that takes an array as an input and returns the first element of the array. Maybe don't look here, but what do you have to do? Create a function that gives, call it get first element. It takes an array as an input and it returns the first element of the array, which is basically array of 0. Cool. Also, maybe let's call it let answer equal to get first element of 1, 2, 3 console.log answer. Cool. Very simple stuff. What is the problem here? First, okay, write it. I'll give you guys 15 seconds, catch up, and maybe write this function yourself. Cool. All right. What's the problem? You'll hover over here. It says array has an implicit any type. If you run it, it'll still work because as we discussed in the last class, Replit doesn't really enforce types, but we should. If there's an error somewhere, we should fix it. What should the type of this thing be? It should be an array of numbers. Question is, until now, we have not discussed this. We have discussed basic interfaces. Interface, I don't know, let's call it user, which could have like a name, string, age, number. We've also discussed basic things like function, I don't know, is even, which takes a number, num as an input, which is of number type. We have not yet discussed an array. Question is, how do you describe an array? It's fairly simple. You can either simply do this. The type of this thing is number and followed by an array. So this is very different from how you might have done arrays before this. But this is one way to describe an array of numbers. Similarly, if you have to describe an array of strings, this is the way. The other way is you create a special type. Let's call it number array. And what's the type of number array? It's this. Whoa. Oh, is someone else editing this? Might be. Either way, I guess you guys get this idea. Type number array equal to number array, and then what is the input here? Number array. Okay. All errors have gone away. If you try to run it, things should work fine. And hopefully this is fairly straightforward. How you can describe an array in TypeScript. This can get more complicated. For example, if you have an interface called user, which has name, string, age, number, you can have an interface or type, called users, which is a user array. Cool. And if there's a function that takes an array of users as an input, you can simply use this type there, similar to how we've used number array here. Cool. So hopefully this was straightforward. How do you define arrays in TypeScript? Number or string or whatever your type is followed by an array, and TypeScript doesn't complain anymore. One thing you will notice here is if you hover over answer, and if Replit isn't so slow in showing me types, let's just move this code locally. This is just taking too long for Replit to sort of load types. Let's try it one more time. If it doesn't work, we'll just go local. Yeah, that's too slow. I'm going to copy this and move this locally. Maybe you guys should as well. So let's open Visual Studio Code. Yeah, maybe you guys should do as well. Let's open Visual Studio Code, create a new project. How do you do it? Go to terminal, go to your folder, create a new folder here called week 8 TS practice, and then just open it in VS Code. If someone told me I can do this. So for some of you, this might work. Code space dot, that will just open the folder in VS Code. If it doesn't work, just go here, file, open, and 8-TS practice. Cool. I get an empty project locally. What is the next thing I have to do? Create a new file called index.ts. Create of an empty ts config. How do you do that? Terminal, new terminal, tsc -- init. Cool. I'll wait for you guys to catch up. Create an empty file locally so we can test this slightly better than on Replit. I'm going to wait for like 15 seconds. Strongly urge you to follow along because we're going to write a bunch of more TypeScript code. If you write it yourself, it'll be easier for you to understand it and also use it later on. Cool. Let's go back, copy this from Replit, paste it in Visual Studio Code. All right, save. Now if I hover over answer, it shows me something. It says let answer : number. So what is happening here is TypeScript already knows the type of answer is number, but we never really wrote something like this. If you remember from last week, this is how you can tell what a function returns. This is similar to in C++ you write int main, which tells the C++ compiler that this function is going to return an int. Similarly, in TypeScript, this is how you describe what a function will return. If I describe this explicitly, it makes sense. If I hover over it, I get the type inferred as number because TypeScript knows, okay, this thing returns a number. But even if I don't give it this, TypeScript still knows that the value of this thing is number. Why? Because TypeScript is smart. It can do static analysis and it knows, okay, this is an array of numbers, which means if array of 0 is returned, it does return a number. Okay. So this is what's called type inference, and TypeScript is very smart to infer types of return types, infer return types of functions without you having to explicitly define them. Although it's always a good idea for you to explicitly define what a function returns. Why? Because I could also return, I don't know, a string here, and then TypeScript would just infer its type as string. But we as the application developer know, okay, this thing should return an an element, which is why it's always a good idea to describe what the function returns. Cool. So what have we learned? We have learned two things. One, how does a function take, or like generally, how do you define an array type in TypeScript? And two, how does TypeScript automatically infer the type of something returned? And generally, it's a good idea for you to explicitly tell it, okay, this is the type that this function returns. Cool. That's step one. That's the first assignment. Hopefully you were able to write these 9 lines of code. I'm going to give you guys 10 seconds to just marinate this and then we'll move on. Okay. Hopefully this was simple. Let's go back to the slides now. In the slides, the next section is, okay, I think we've already solved this. Okay, how do you, yes. So now I want you to write a function that could take either an array of numbers as input or an array of strings as input, and you have to return the first type. So what do you have to return? You have to return the first element of an array, but the array could have either numbers as an input or strings as an input. So this is what the function signature looks like. Returns array of 0. The JavaScript part is still the same. It simply returns array of 0. But what is different? The input can be either an array of numbers or an array of strings. Cool. Let's go back to VS Code and try to solve it. So this thing now should take an array of either strings or numbers, so that answer 1 is this, and answer 2, let's say, is the inputs are strings. As you can see, TypeScript is already complaining. It's saying string is not assignable to type number, which means you can't put a string here. TypeScript knows that this function signature says it needs to be a number array. How do you fix this? You can simply say, okay, it is of type either string or number array. So what have I done? I've said array is not number array. It is either string or number array. If you want to write it more cleanly, you could do something like this. I'm going to command Z here. I'm going to say number array equal to either number or string array. You can define it separately. Cool. type number array. Maybe let's rename it. Rename it to input. So type input is either a number or a string array. So it's an array of either string or a number, which means you can also have this as an input. I think it'll work. Yeah, exactly. But let's just stick to the original requirement of this and this. Cool. Now return starts to complain. Why does return complain? It says TypeScript is smart enough to know okay, input is either a string or a number array. So array of 0 will either be a string or be a number. So I can either completely remove it and it will use type inference to get the type of these things, string or number. What is answer to? String or number. Or I can explicitly define its type. Be like, okay, get first element takes an input, which is an array of number or string, and returns either a number or a string, because that's what array of 0 is. Cool. So this is how what have we done? What extra have we done here? We've just understood how you can change the function input to be an array of either string or a number, not just a number. Cool. Going to give you guys 10 more seconds to try this out locally, maybe 15. Try it out locally, maybe try to run it as well. How do you run it? Save tsc, enter, node index.js, and you see 1 as the log. What is 1? The first element of this array. Similarly, if I log the other thing, I think you guys get the idea. Run tsc again, node index.js, I get 1 and then one. Cool. So slowly we're making our functions more and more strict. Cool. Let's move on. I'm going to go to the slides. Hopefully you were able to follow along and write all of these locally. And this is what you see on your VS Code as well. Back to Chrome. So what I just discussed is the dumb solution. Why? Let's see. We were able to solve this string or number array, but this is the dumb solution. The problem is, if I hover over A, it says string or number, rightfully so. As what are we returning here? It is a string or a number. Even if I don't give it this, I can either, give it an explicit type. What am I doing? This is good. I can either give it an explicit type, okay, it returns a string or a number. Even if I don't give it an explicit type, it infers answer 1 as string or number. It also infers answer 2 as string or number. The problem is, we know, like if I'm writing the code, I know I gave it a bunch of array integers as input. This thing should be a number. Ideally, this function should be able to figure out somehow, okay, if the input is numbers, the output should be number. If the input is a bunch of strings, the output is a string. Cool. So this is good. This is not bad. This is very decent way for you to write this function. The problem is, if I try to, we know answer 2 returns a string. I also know that string.toLowercase is a function in JavaScript. If there is a string in JavaScript called str abc, I can do str.toLowercase and it will give me abc in lowercase, which means this will output small abc. If I try to call the same function on answer2, which should be a string because the inputs that were sent were a string, it gives me an error. Why does it give me an error? It says property toLowercase does not exist on type string or a number. It says property toLowercase does not exist on type number. So TypeScript actually gives you very nice explanations. It says you are calling toLowercase on something which can either be a string or be a number. This thing returns a string or a number. That's what TypeScript knows. TypeScript doesn't yet understand, okay, if the inputs were a string, the output will be a string, and hence what you will see on the left would be a string and not necessarily a string or number. In no case will, if the inputs are strings, you get back a string or number. You will simply get back a string. But TypeScript doesn't know it yet. So all this mumbo jumbo we did just to understand one concept in TypeScript, which I'm going to introduce now. But do you guys understand the problem at least? The problem is, we want to write a function which takes an input which could be a number or a string, but the type that is returned should be either just number or just string based on the inputs that you've sent. Okay. We want to tell TypeScript to infer these types correctly. We as the application developer know this, but TypeScript isn't yet as smart. Okay, it will be able to figure out, were the inputs strings or were the inputs numbers? Cool. This is the problem we want to solve. We will get there, but before that, please try to catch up until this point. I don't think I've written anything extra actually, so I think you guys are still there. This can still be string or number. So let's just keep it this way. Right now takes input as this, returns output as this. If I just try to do return number, it will throw an error. It will say if the inputs are string, then the output won't be number. If I just try to return string, it will still create an error. Hence, this is the right way to write the function until now. And this is the sort of only way for you to write a function like this. Now let's try to optimize it a little bit more and try to give it more stricter types. And again, why are we doing this? Because when you're writing this in a very big project, you might want to call str.to lowercase, or more specifically answer2.to lowercase. But you won't be able to because TypeScript will say it doesn't yet exist on number. It does exist on string, but it doesn't exist on number. As you can see the error, it only complains for number. And it doesn't yet know, okay, this thing is a number, is only a string, it's not a number. Cool. To fix this, I'm going to introduce something. So what is the problem? The problem is it returns either a string or a number for the second one and the first one. It should return just number for the first one, just not return, infer number for the first one and string for the second one. Why is this a problem? Because if you try to call to lowercase, it will complain, okay, this type doesn't exist on number. Even though B has to be a string, it can in no case be a number. Ugly solution one. Ugly solution one is simply create two functions. Create a different function for number array and a string array. This will return number, this will return string. For the first one, call the first function. For the second one, call the second function. And then b.to lowercase will work because the type of b that is inferred will be a string, because this function only takes string array as an input, and hence what it will return will be a string. So this is the ugly solution that you shouldn't do. Why should you not do this? Because whatever logic you're written here is repeated. If you know that the logic or the manipulation that you have to do on an array is the same, there is no point for you to define two different functions just to fix the types. There are better ways of doing it. What are those better ways? That's what I'm going to introduce next here. I'm going to introduce this ugly thing that you might have seen in some languages, might have even seen in TypeScript in a few places. This opening bracket, T, closing bracket. These are what are called generics, and these exist in all sort of strict languages, not just TypeScript. They exist in C++. They've actually been brought here from other type-safe languages because it's a very common pattern to use when you're dealing with a use case like this. What is the use case? The use case is the body of the function is the same, but the types that it takes as input and the types that it returns are different, but the body of the function is the same for both the types. To solve this problem, there is this thing called generics that exist not just in TypeScript, but in other languages as well. Let's try to understand what those are. Okay. Let's try to understand what are generics generally. So let's look at the function. What does it say? It says get first item, just like the function that we had. And then it has these ugly braces and T in the middle. This could be T, this could be U, this could be LM, NOP, whatever. T is generally used as the standard. T stands for template. So this is the template that you want array to have. What should an array be? Array should be of type T array. Okay, now this might feel confusing. Until now we have seen string array, we have seen number array, we have seen string or number array. But what is T array? It basically means okay, whoever is calling this function, if they pass in numbers as an input, then T becomes number. If they pass in strings as an input, then T becomes string. So it is a generic function. It is like, I don't care. I should get an array of something which I'm going to name T now. And if the thing that is passed is a number, I will return a number. So this function, what will it return? TypeScript is smart enough to figure out if the input is a number array, you get back a number. If the input is a string array, you get back a string. If the input is a T array, where T is a generic, and you return array of 0, what this function returns is actually T itself. Okay, too many things. Let's try to code it. The only syntax changes, rather than doing get first item array of string or array, we are doing this, string or number array. We have introduced this part and we have introduced this part. Everything else is the same. You will notice no runtime changes have been made. Only changes have been made here when you are defining the arguments. Let's try to code it and let's try to see how this works locally. Cool. Okay. So let's get rid of this input. We don't need to define it anymore. What was the first thing we did? Opening braces, capital T, closing braces, and array should be T array. Let's not yet worry about what it returns, even though it should be very easy to figure out that it returns a T. If input is T array and you're returning array of 0, of course you're returning T, because if the input is int array, you will return int. If input is string array, you will return string, which is why this you should be able to, even if you don't want to do it, don't worry about it. Just this much if we write, and now if we hover over answer 1, it says answer 1 is number. It doesn't say answer 1 is string or number. In fact, you will notice I have not written strings anywhere. I have not written string as an input. I have said T, which means input can be anything array. And what I return, of course, if I return array of 0 will be the type of this thing that's been passed in. What am I passing in here? An array of numbers. So T becomes a number because TypeScript knows okay, the input that is being passed, if the array is of type T array. If each one of these is numbers, which means it means that T will be a number and hence it will return a number. Similarly for strings, if you hover over this, you will see the type of this is string. Why is this cool? Because now I can simply write answer2.to lowercase. TypeScript has been able to infer that the type of this thing is a string. Now you might ask, how was TypeScript able to do it? One, it knows that input is a T array. You gave it a string array, so it knows okay T is string. You can also explicitly tell it, okay, bro, the template for this function that I am using here is a string. The template of this function that I'm using here is a number. That way, you're explicitly telling it, okay, this should be a number array, which means T is a number. And then TypeScript is smart enough to figure out if the input is a number array, you return a number, and hence you see type inferred as number here. Why did we do all of this? Because we wanted to make our types more strict. How did we do it? We said the input takes a generic as an input and returns the same generic array as an input and returns the first element of the generic array, which will be the actual generic, which in this case is a number, this case is a string. You can extend this to as much as you want. You can create a more complex type here. Let's say you have a user type which has name, string, age, number. You can be like answer 3 is get first element of user, which means each one of these is going to be a user which has a name, an age, if I hover over answer 3 now, you get back user. Cool. Hopefully this was clear. Going to do a poll now. This much is good enough. You don't have to write the third one, but hopefully you understand why or how you can use these things called generics and why they are useful. Only if 85% of the people understand will we proceed, else I'll try to teach this again. It's only 7 lines of code. Going to do a poll now. Oh wow, pretty good, pretty good. Amazing, very good. 92% understand, which means we will proceed. For those who don't understand, either you have not done TypeScript, basic TypeScript until now, or you can just come back to the video. I'm going to proceed, and now if 92% of you actually understood this, firstly let's read the definition of generics. Generics, I mean, just go through this very quickly. It will basically memorize this whole thing for you. Generics refer to a programming concept that allows the creation of classes, interfaces, or functions, which we have done, that can work with different data types while maintaining type safety. In other words, generics provide a way to write reusable code that can operate on various data types, string array, number array, without sacrificing the type checking at compile time. Cool. Compile time type checking works fabulous, and the logic that runs at runtime remains the same. So this is what a generic is. Sort of hard to ingrain this for the first time, but it seems like 92% got it. So that's great. So I'm going to give you a harder assignment. The assignment is create a swap function that can take 2 arguments of the same type. So either number or string or user, whatever you want, or booleans, the function should swap them and return an array with the first two element reversed. Basically, the arguments are a and b. It should return an array, the first element of which is b, the second element of which is a.